Hello there. Today we're taking a look at the Godot game engine. And here's the website. It's mainly centered around two-dimensional or 2D games. And it's written in C++. I was able to download it. And I can play demo games here. I'm not going to show that this go round because I don't have a lot of time today. So I'm just going to go through quickly, and the plan is to come back to take a look at it more in depth at another time. Here's the GitHub page, and what I'm looking for in this stream, this video, is to get a sense of more of how the graphics work, and not just the graphics, but we in the last two videos we took a look at MAME, which was an emulator from the arcade era, which, if I remember my history correctly, spans like the 1970s, 1980s, maybe up into the 1990s. Then yesterday, we looked at ScumVM, which is used to play point-and-click adventure games, really from the 1990s era. I think they probably bled over into the 2000s. And the idea of looking at Godot is it seems to be a fairly complete game engine. And now that we've kind of have a grounding in the history of how some of these games used to work, I'd like to get a sense of what something more modern looks like. And this may not be the fanciest game engine. It might be the fanciest game engine. I don't really know. People seem to like it, and it's open source. It tells me here that it also does 3D games. I was under the impression it was mostly 2D, or maybe that it specializes in 2D, or that it excels in 2D. But it should at least give us a feel for what a game engine should look like. Here's a screenshot. It's got this is kind of a traditional view for creative software. In the middle is the thing that you're working on. Actually, you know what? I can pull this up. Let me see. Let me see if I can just execute the Godot binary. Yeah, okay, so I have it pulled up. I downloaded Top-Down Action RPG, which is when I opened the program, it told me I didn't have any games or whatever, and it offered to let me download a bunch. And this is just the first one that showed up, so I downloaded it. And if I open it, I should be able to see some assets and whatnot. So we've got this intro.tscn file. I don't know what T means. SCN might be screen. And then in the middle, we have this, as I said, the thing that we're looking on. I'm not sure what they call it. It's kind of like a viewport. Above, I've got 2D and 3D toggles. If I click on 3D, it's this three-dimensional Euclidean space thingamajig. We've got the XY plane, and it's tiled by squares. And then we've got the X, Y, and Z coordinates. I'm guessing just by convention that X is red. Okay, yeah, up here we see that X is red. Oh, Y is up. So Y is this vertical green line, and then Z is blue. And I guess I can click this thing and rotate around. I'm sure all of this is relatively standard. I think it's pretty similar to Blender, which is the only other real 3D software I used. And then I've got scripts and asset lib. And asset lib seems to be populated with a bunch of stuff that I certainly haven't added here. These seem like things that maybe I can download. So I can maybe download Particles 2D. Yeah. Okay. So that's kind of what's up with the UI. And then on the left, we have various docs or panels that will let us compose our game. So we've got some color rectangle, a logo, these are, I guess you would probably call these assets, right? And then on the right, we've got like digging into this, whatever we clicked on the left, we've got more stuff that we can do. Like we can modify the rectangle, we can modify the grow direction. I'm not really sure what an anchor does. There's a texture rect. Okay. And then we have like file system in case I want to pull in stuff that is on the file system and not yet, I guess, imported into Godot. On the right, I also have node. I'm not sure exactly what it's doing with these nodes, but presumably they're part of some graph that we'll see Godot build up and manipulate. There's a debugger, some audio stuff, I guess like a mixing board, and animation, and output. Output kind of just looks like maybe a log. And I think if I press the play button, I can play this game, and I'll open up the audio just in case it's loud. New game. It says game title. Nice. Okay. And some sort of bug, I guess. Okay. And then I can swipe people or whatever. All right. So this is like a demo game. If we dig in, we should be able to see like where these bug assets are, and maybe that's worth doing, I guess. All right. So let's go ahead and close this top-down RPG. Actually, let's also get a string. I saw some text on the screen. Can I swipe this guy? Or is this person my friend? Okay, obtained bandit heart, something or other. So if I grep for bandit, I should be able to find something. Let's see. Intro. And then what is anims? Okay, so I clicked on anims, and then I'm down in this panel. I've see some stuff populate. Color, rectangle. It looks like it's got a sound wave. Audio clips is what that is. Logo, boog. I don't know if that's big or bug. Okay, so we've got, so in file system, we've got item collected, which I guess played when I did things. Dialogues, looks like a dialogues.gd. I guess this is a Godot file. This is the dialogue system. Any object can send text to it by doing dialogues.showDialogue. And we have, here's kind of like the syntax. We have signal dialogue started, signal dialogue ended. This maybe looks like JavaScript. It's been a while since I did JavaScript. I think you like var this equals foo. We've got func show dialogue, text string, speaker string. If is instance valid, dialog box will show dialogue. And this is mostly like error stuff. Okay, so globals. We can save game and some stuff. All right, inventory. What about textures? I'm curious. I want to see whether these are okay. Yeah, so mushrooms I recognize from the game. The item, this kind of money bag thing, I recognize from the game. I don't remember the table, but this seems to be actual assets from the game. I don't know where the bug is. There's smoke, arrow, heart, logo. All right. Various things. It'd be cool to find them. Okay, let's see. Music makes sense. Scenes. Okay, characters, items, levels, miscellaneous, and props. What's a prop? Props are flowers, grass, house, mushroom big, and table. And the props kind of have this clapboard logo, which I think is supposed to be one of those old, clapboards where they used which they used to synchronize sound on old movies. And so that seems to make it seem like this is supposed to be a video, but I don't know if this is a video or not. Oh, so whatever this is, miscellaneous, just different things. Okay, so items, all right, and then characters. Debug character, enemy. That's the GD file is the script. The TSCN is also as the clapboard, so it's some sort of, I guess, graphical asset is what I'll think of it as. I don't know if that means it's a video or something. So, and here's a bug. Select an animation player node to create and edit animations. So what can I do with this thing? I can open scene, which I think I just did by clicking on it. But now, do I have any options to like make it do interesting things? I can go into ruler mode. I'm not sure. Well, we will learn. Script changed. Play scene. I can play the scene. Does this just open the game again? Okay. So it is kind of like a video. When I play this scene, this bug is going to bounce up and down like it's just waiting for something. But that doesn't match what the icon is. This bug is bouncing up and down. Does it move? Yeah, okay. Huh. All right, so this scene includes what? So Godot has this notion of a scene, and the scene seems to include the animation and also the controls. So I can like move this bug around. Can I swipe with my sword? Yeah, okay, I can swipe with my sword. So can I unravel this object? I'm not sure. I'm gonna try opening this file in Emacs to see what it does. And let's see. In player.gd, this is the Godot file. And we can take a look at how it's implemented. This implements a very rudimentary state machine. There are better implementations in the asset lib if you want to make something more complex. Also, it shares code with enemy and probably should extend some parent script. Well, you don't have to. Okay, so it's got it's got a walk speed, a roll speed. I don't think I know how to roll. Hit points, linear velocity, roll direction. And here's what we can do. Up, down, left, and right. var facing equals down. So I guess you start maybe in the down position. Despawn effects is going to preload despawn effects dot whatever t scene is. I don't know what it means to set animation to star, or is it quote end quote? It's hard to tell on this. Okay, yeah, no, that's quote. It's an empty string. And then we have this enum, and the enum doesn't seem to be assigned to a value, right? There's no like equal sign unless I'm missing anything. Okay, but this enum has various states: blocked, idle, walking, attack, roll, die, or hurt. And the state is equal to state idle. And func underscore ready. I'm guessing maybe since this is an underscore that this is kind of like a standard entry point for the script. We're gonna the spawn points are gonna be equal to get tree, get nodes, and group spawn points for spawn points in spawn points. So we're gonna iterate over the spawn points. If the name is globals dot spawn point, then global position equals spawn point dot global position, and we're gonna break. I'm not sure what global spawn point is, and so I don't know what this logic is trying to do. And then there might be some error dialogues. And then func physics process. And it's going to take in a delta. I don't know what an underscored delta is. So again, this is underscored, this is underscored. Let's just, for the sake of argument, open up something else. How about house inside? I still seem to be on player. And yet, okay. Yeah, I don't know. I'm confused by this by the UI, but that's okay. Is this real? So this still is player. So where's house inside? Who knows? Okay. So so we've got this underscore physics process thing, and it's going to take a physics delta, which I just accidentally clobbered. Process states. And we're going to match state. And so I guess this is like when a change happens, this function is going to be called, and we're going to look at state, which is, I don't think it's defined here. It's probably maybe like a global variable. At any rate, it seems like whenever something happens, like a clock tick or however the game decides that progress is going to be happening, we're going to check the state, and if it's blocked, the new animation is the idle, and it says it's idle facing, so like idle down, idle up, etc. If you're already idle, then we're going to check for action events, like whether you're supposed to be moving up or down, and we're not doing it at the keyboard level. We're looking at the keyboard, whatever's going on in the keyboard or the mouse has been processed already into something like move up, move down, into a command. And then this file is interpreting that command. And if you're doing an attack, then you change the state to attack. And if the action is roll, then you do a roll. And if you're walking, it's kind of the same thing. You can attack, you can roll, you can move up, left, right. Yeah, okay. And up here, if you move, the state changes to walking. So we have the state transition logic here. So what is the attack state? So you should go from the attack, you should go back, after the sword swiping is done, you should go back to whatever you were doing during the attack, whether walking or whatever. Okay, so if you're in state attack, then the new animation is slash facing, so like slash up, slash down, I guess. If you're in state roll, if the roll direction is 0, the 0 vector, you're going to stop. You're going to go idle. Otherwise, you're going to move and slide with the linear velocity, and your target speed is going to be given by your roll direction and roll speed. And if your state is die, then you're going to die. If you're hurt, you're going to hurt. And then at the end, we're going to update the animation. If new animation is not equal to the animation, we're going to set animation to the new one, and we're going to play that animation using this variable. Cool. So how does it stop attacking, though? So all that attacking does is play a new animation. So perhaps at the end of the animation, I don't know. I feel like after you're attacking, you should, like if you started idle, you should go back to idle. I don't see where that happens. Maybe that happens like after the animation is played, it does something else. Okay. Helper functions go to idle, update facing, despawn on hurt box area entered. If state is not state die, then we're going to decrease 1 hit point and emit signal health changed. And I guess that's so that any other routines that depend on health change information see that. We're going to push back direction, global position minus area global position normalized. And then we're going to move and slide in the push back direction. So we're getting some vector. And I guess when we get hit, we slide back due to the force of the hit based on that vector. We're going to set the state to hurt and hit point. And, if we lost all of our hit points, we're going to die. What did state hurt do? State hurt plays the hurt animation. Okay. Okay, and that's all there is to the script. So that's all that this character can do. Can I find the animations? So maybe the animation is kind of like bound up somehow in this player.tscn. Let's see. Player.gd. I want to open this. Open scene. I don't know. So let's get rid of all of this stuff and see what opening a scene anew does. Okay. So we're at player and we've got the sprite. Sub-resources. Texture. Let's look at the texture. I don't know. All right, hitbox. Sub-resources shape. Add child node, attach script, move up, move down. Open documentation, delete node. I don't think this is collision shape 2D. All right, great. Oops. And animations. Oh, wait, maybe I should have been looking down here. Okay, so here are some of the animations. It looks like this is, it's hard to see this, but, oh, okay. What does a roll animation look? This is the roll animation. Can I play it? This looks like the play button, but it also looks like forward play. Huh, that looks like a shadow. Let's look at the hurt. So when it dies, it's going to spin around. What does this play backwards? All right. And what else? Hurt. What does it look like when it's hurt? Doesn't seem to do anything when it's hurt. And then roll again. Yeah, okay, so it's got this kind of bouncy stuff. All right, cool. Then we have camera. Oh, okay, so this red cross is showing me where the camera is, I guess. We can debug, and then we can look at the hurt box. Oh, okay, so this oval is the hurt box. So if you hit anything in the oval, that thing gets hurt. What is the, I'm wondering what this circle on the bottom is. Okay, slash is this kind of two triangles and a 1, 2, 3, 4, 5 and a pentagon. Is that where, is that everything that can be slashed by this guy? Where did attack go? Slash left. Let's look at slash left. Okay. So slash left, yeah. So slash left is going to stay within this red triangle. And then I don't know what these other two triangles do. Hitbox here is just this, this circle down here. I don't know the difference between hitbox and hurtbox. And then that's the sprite. Okay. So that's pretty cool. I don't know what GLSE2 or 3 is. And I think I just started this scene. Okay, so now that we've seen that, maybe we can just go back to the beginning and play the whole game. Does this play the whole game? I still don't know how to roll. Yeah, okay, so when I hit this person, they jump back. And when they die, they spin around and poof. Cool. All right. So that's the game. We can go back to looking at the source code now. Yeah, quit the editor. Actually, I think I said wait, I don't have the source code downloaded, so I can't open any Macs. All right, so that's what the UI looks like. So let's take a quick look at the code. We've got modules, platforms, scene, servers, which I will assume is for playing online somehow, tests, third party. Out of sheer curiosity, I'm going to look at tests first, and then core, editor, main. I don't know what the difference between core and main is, but it seems like we should look at editor, core, main, and scene. And I think that's about all I have time for. All right, so here we're in tests. Seems like pretty good tests. Let's see test main.h. What's going on? We're going to int test main. Where's the actual tests? Test main.cpp. We're importing a ton of stuff, as we should. Let's just zoom out and take a look at the file. Seems pretty good. The imports are longer than the test itself. If test commands, run custom test tools. There's a doc test runner. Convert Godot command line arguments back to standard arguments. Godot test case listener. Signal watcher. Physics server 3D. Yeah, I'm not sure what's going on. Test case end. If scene tree gets singleton, blah, blah, blah. Cool. Yeah, it seems like they put some work and some thought into the tests. Here's main. There's not a lot going on in main. There's performance.h, which I might as well look at. And then let's look at main h and main CPP. In fact, let's do that before performance. All right, we can print help, last ticks, hide print FPS attempts, frames, force redraw request, integrating, agile input event flushing. We'll check if tools are enabled. We'll check if tests are enabled. And there's not really much there. Here's main.cpp. We are going to import a bunch of stuff from core, mainly from core, but also some main stuff and some scene stuff and some server stuff. And depending on if tests are enabled, we'll do some other stuff. We'll define a bunch of things to be null pointers. And these are all initialized later. This is, I guess, kind of lazy initialization. Although you run the risk here, you have a bunch of pointers that are nullable. So that that could be a source of bugs. There's probably another way to do lazy initialization in C++, but I don't remember offhand the right way to do that. And then we've got some functions. We're going to check it for a command line tool. We can get a version screen and we can initialize physics. Fix me could be moved to have less code in main.cpp. So we're going to set the physics server 3D to be the physics server 3D manager. So maybe I should look in server if that's the physics server, if that's what they're considering a server. Finalize physics. We're going to finalize the 3D and the 2D physics thingamajigs. We're going to finalize display. Initialize navigation server. So it seems like maybe physics and navigation are kind of conceptually thought to be services provided by, provided as a service. I don't know if they're in the same process or what. They're probably in different threads, I would suspect. Okay, so we're going to print a bunch of stuff. A bit like the help text. And some test stuff. Some tool stuff. Engine initialization. Main setup. Engine startup begin. Startup benchmark begin measure. Parse command line. Mini zip enabled. And then we're going to do a bunch of flag parsing and processing. And this looks a bit complicated. Initialize the user data directory. Check to see if Vulkan is enabled. And if it is, we'll do whatever forward plus mobile. I don't know what GLES3 is. But we'll check to see if it's enabled. A bunch more engine stuff. Get singleton, set physics ticks per second to be global default, probably basic, property info variant int, physics common, physics ticks per second, property hint range 100160. I guess that means 60 ticks per second. Set maximum physics steps per frame to be default, I guess 8. Set physics jitter fix to be 0.5. And whatever this is, max FPS, I guess frames per second. All right. So there's a lot going on here. Seems like mainly bookkeeping. Okay, performance.h. GD class, monitor call. We've got time, FPS, time process, time physics, memory. So I guess this is maybe keeping track of how long things take and how much memory they take, how many objects there are in memory. Render total objects in frame. I guess maybe how many total objects have we rendered in a frame. Navigation edge count, navigation link count. Okay, so this is keeping track of metrics. Bind enum constant. All right. All right, so here's the Godot /core directory. I was hoping there might be a README, but there's not. Okay, so there's crypto. I don't know why we need crypto, but let's look at crypto. We got AES crypto core hashing. What is SC sub? This is a Python script. I'm not sure. Okay. Well, we have crypto. We've got config, errors, extensions, input, math, object. What is object? Method bind. Class db make virtuals .py. Define gd virtual blah blah blah. If virtual name. Yeah, I have no idea what's going on. Generate version. Core bind.cpp. Let's look at core bind. Resource loader. We're going to load threaded request. Resource loader get recognized extension for type. Has cached. Bind methods. Class db, bind method, d method, load threaded request, path, type hint, use subthreads, cache mode. I'm wondering if this is the implementation of the Godot language. Type defs, core globals. Let's look at core globals. It'd be nice to have more comments. Home for state needed from global functions that cannot be stored in the engine or OS due to, for example, circular includes. And we've got leak reporting enabled, print line enabled, and print error enabled. Yeah, I feel like I don't know what's going on here. Let's look at nodepath.h. Safe ref count. So we've got a reference count. We've got some vectors, a vector of string names of paths and subpaths, and then concatenated paths is absolute. Prepend period. Are these file paths or node paths? I don't know. So let's look at scene. Okay, we've got 2D scenes and 3D scenes. We've got animations, audio, debugger, GUI, main, I guess. Register scene types, properties, scene string names. So scene 2D, we've got animated sprite 2D, camera, back buffer copy, audio stream player, collision object, joint, light, line builder, mesh instance, navigation link. Where's a navigation link? And we've got this class DB that binds stuff. Start position, set travel cost. Disable that navigation link 2D. I don't know what a navigation link is. Navigation link 2D notification. P what notification enter tree. If enabled, navigation server 2D get singleton, link set map, link get world 2D, get navigation map. Ray casting, skeletons. Yeah, let's look at skeletons. And sprite, and I guess tile map. All right. Okay, skeleton 2D. All right, we've got bone 2D is parent bone. Skeleton 2D is so we've got a parent bone, a skeleton, and rest, which is a transform 2D. Auto calculate length and angle, tools enabled, notifications, set rest. I don't know what rest means. Auto calculate length and angle, skeleton modification stack 2D. And then we've got a struct bone, which is going to have a 2D bone, a parent index, and some other stuff. We can call get skeleton, and it's going to return a rid. All right. So bone 2D get property list. We're going to push back some stuff. Property hint, property usage default. If auto calculate length and angle, we're going to push back variant float, pname length, property hint range. Yeah, huh. Bone 2D notification. Parent bone, skeleton. Okay. Notification draw, tools enabled. Yeah, I'm finding this a bit hard to follow. I don't know if that's because I just don't know anything about game engines. But for example, it's got all of this like property info stuff. And I'm guessing these might be like, because they're in all caps, they might be like templates or something, or macros. And canvas set parent. And there's also a lot of these if defs. So like if tools are enabled, do this and that sort of thing. So it's kind of hard to see at a glance what all the logic is doing. If P align shape, and there's also not many comments. So that makes things a little bit more disorienting. Okay, so bone calculate length and rotation. If there's at least a single child bone 2D node, we can calculate the length and direction. We will always just use the first bone 2D for this. We said it is calculated to false. We're going to get the number of children. If there's more than one child, if there's any children at all, we're going to iterate over them. We're going to cast the bones to bone 2Ds. I'm not sure why they weren't bone 2Ds in the first place, but if the cast was successful, I don't know what toLocal is. Maybe it normalizes the coordinates of the bone. We're gonna get global. Oh yeah, okay. So get global position is maybe like the coordinates in a global chart, and then toLocal is going to normalize those coordinates maybe relative to the parent bone. We're going to set the length to the child bone position length. We're going to set the angle to the position normalized angle, and then we'll set calculated to true. So that's not really doing any work. It's just calling out to the existing functions, and then maybe toLocal is a little bit of work. Okay. So, and then a skeleton 2D should be a collection of bones of some sort. But let's look at skeleton 2D update transform. If bone setup is dirty, we're going to update bone setup. So I guess dirty means if it's been modified since we last looked at it. And if the transformations are not dirty, we're going to just return. I'm going to say transform is not dirty. And for iterating all of the bones, error continue bones, the parent index greater than or equal to 1. I don't know what error continue is, but I guess it's an error. Maybe if the bone parent index is bigger than or equal to 1, but we're going to continue processing anyway. And if bone, if the bone that we're iterating over, if its parent index is bigger than or equal to 1, we're going to write at index I a cum transform is equal to bones at I parent index dot a cum transform times bones at I get transform. I don't have a sense of what that's computing, but okay. And if we get a notification, we'll say if p what is equal to notification ready. So the notification comes as an int. So really it's kind of enum. If it's notification ready, then if bone setup is dirty, we're going to update bones. If transform is dirty, we're going to update transform. Otherwise, and then we're going to request ready. If it's transform changed, we're going to do some other stuff like get global transform. If it's notification internal process, if modification stack is valid, we're going to execute modifications, get process delta time, skeleton modification to the execution mode process, and whatnot. Cool. Sprite 2D. So for sprites, I'm just curious what makes up a sprite. Okay, so sprite has a texture, a ref to a texture, a specular color. I forget what specular color is. Let's see if Wikipedia has it. Specular highlight. Is it the bright spot? Maybe it means a specular color map or mask. We can use a bitmap file or a procedural map to apply an image to the material's specular color component. Okay, so this is like reflection highlights, but it's a color and not like a map, I guess. Shininess, whether it's centered, offset, H flip, V flip, region enabled, region rectangle, frame. I don't know why sprites need frames. V frames, H frames, get rects, and texture changed. We can validate properties, and we've got some getters and some setters. So here's the sprite implementation. So get rectangles, we're going to do some calculation. Is pixel opaque for a point? And it's actually a pretty, let's find out how to know if a pixel is opaque. So if there's no texture, then it's false. There's the pixel's not opaque. If there's a texture and the get size is and the width is 0 and the height is 0, then it's false. That's like a degenerate texture. We're going to declare some rectangles, a boolean for whether clips are enabled. We're going to call getRects with those things, which appear to be not pointers, and they appear to be null. So let's see if I can find getRects. GetRects is void. Oh, it does take a reference. Okay. So we're passing those in as reference. What was it? Where was I looking at? Is transparent or is opaque? Is pixel. Here we go. Okay. Yeah. So we're passing these in as reference. And so this is just like setting those things as output parameters. And we're going to get the absolute value of rectangle size. And if, I guess, the rectangle doesn't have the point that we're passing in, then we're not opaque. We're going to check if it's flipped. And if so, we're going to adjust the flipping. To do this needs to be obtained from canvas item new repeat mode, but it needs to guess it from hierarchy. Need to add a function for that. Bool, so we're going to set is repeat to false, is mirrored repeat to false. And then we're going to try to compute whether it's repeated or not. And then we're going to call texture is pixel opaque with the stuff we computed. Okay. Fun time for tile map. I'm just curious what's in a tile map. We've got a dirty list element, self-list, tile map quadrant, dirty list element. I guess those are parts of the tile map that have been interacted with or changed, or that need to be redrawn. Quadrant layer and coordinates. Tile map cells, which is a vector 2i. I don't know what a vector 2i is. We need these two maps to sort by local position for rendering. This is a kind of workaround. It would be better to sort the cells directly in a cell set instead. And we've got some rendering. So canvas items, debug canvas items, bodies. I don't know what an RID is, but maybe some sort of physics body. Vector 2D navigation regions, scenes, and runtime tile data cache. Okay, and some terrain variables. I already looked at navigation link 3D. So here we are on Godot /scene 3D, and we've got 3D bones, bone attachments, area 3D, collision shape. I'm sure that's some of the stuff we were looking at when we were looking at the bugs. Decal fog volume. Let's look at fog volume. Light mapper, marker 3D. Is this just like a 3D point? Navigation agent, raycast, shape, spring arm, sprite 3D, voxel. Okay. So let's look at fog. It doesn't tell us what it is, but we've got fog volume shape is equal to fog volume shape box. We've got a material, a vector 3, and we're going to force inline RID get volume, which I assume is an optimization. Okay, what is marker 3D? It's a type of node 3D, or it extends node 3D, and realT gizmo extents equals 0.25, bind methods. I don't know what that is. So animation has got animation blend space, animation player, animation tree, erasing equations, root motion view, tween. All right, so let's look at the tree and the player, just the header files. So we can set a tween. We've got property tweener, interval tweener, tween process physics, translinear, transbounce, transback, transmax. We can ease in and ease out. We've got current step, loops, speed scale, start tweeners, bind node, and a bunch of other stuff. Duration. Okay. Animation tree, I'm guessing, is a tree of animations. And we've got nodes And I don't know what the tree structure is for. Maybe it's like a layered animation, and we're only gonna animate the stuff that's not occluded or something. So we've got a time delta vector blend seeked is external seeking, state track count hash map. So track count, I'm not sure what that is supposed to be. Track map, animation states, which is a list of animation states, animation player, animation tree, pre-process. We can get filters. We can blend animation, blend node. Let's see. So let's see, what does blend animation do? It's going to take a p animation, which is a string name. It's going to take a p time, a p delta, a p seeked is external seeking, p blend, animation looped flag, animation looped flag none. I don't have a sense of what it's doing with those parameters, but that's okay. Track cache. Root motion is false. Setup pass is equal to 0. Animation track type is equal to type animation. Set some stuff to the null pointers. Is this the destructor? No, it's just destruct. Okay. Animation player. Now we've got bind methods again, update skeletons, and restore. So with an animation player, you can update the skeletons, and that's about it. Oh no, this is animated values backup. That's the class. So what about animation player? So we've got animation process physics, process idle, process manual, animation method call deferred, animation immediate, node cache update max, blend from max, a track node count, audio animation, play audio stream info. Ensure node caches. Yeah, okay. And then here we are in Godot scene main. We've got a canvas item, instant placeholder, missing node, multiplayer API, node. I guess let's look at node, scene tree, and viewport. Okay, here we are in main/node. And node has, we're going to define viewport, windows, scene, state, tween, property tweener. We've got a comparator, which I guess that's going to help us decide whether, yeah, okay. That's going to be for, I guess, sorting nodes. Comparator with priority. That's also presumably going to be for sorting nodes, maybe to see which one is occluding the other or something like that. Data is to avoid namespace pollution in derived classes. Instance state, inherited state, parent, owner, node. This looks mainly like graph stuff. We've got a giant enum. You can make your own, but don't use the same numbers as other notifications in other nodes. So these are notifications. Enter tree, exit tree, moved in parent, paused, unpaused, VP mouse exit. So I guess these are things that can happen to a node on the scene. And then viewport, class, camera 3D, collision, object, audio listener, world 3D, canvas layer. Okay. What do we got? Different scaling modes, some stuff about quadrants, some stuff about screen space, some debug stuff. I still don't know what RID is. And then Godot/editor, which I'm mainly not going to look at. This is, I guess, the thing, probably the thing that I looked at in the beginning that lets you edit the various things. Let me see if I can find out what an RID is. Test RID. An RID owner. Light storage, text server. Oh yeah, and I wanted the peek-in server. So let's look at test RID. This should import whatever, yeah, core templates RID.h. Okay. So here's core templates RID owner.h, RID.h. And there's no comment. Is there an RID.cpp? Maybe if I just do Godot RID. Handle for a resource's unique ID. Okay. Cool. Okay, so that's the, we get a ring buffer. All right, so let's look in servers just to see what's in servers. Audio, camera, debugger, extensions, movie writer, navigation, physics 2D, physics 3D, rendering, text, XR. Don't know what XR is. Physics server 2D.h, physics server to 3D.h, rendering server. And in fact, I'm going to look at the implementations of 2D and 3D because that's where they will be importing, I think, any external dependencies. And then here's navigation, navigation path query, navigation query parameters, so we can query stuff. How are we querying? Do they have their own query language? Get parameters, set pathfinding algorithm to some pathfinding algorithm. Where's pathfinding algorithm defined? Variant enumcast. Maybe let's look at the CPP. Navigation utilities. Pathfinding algorithm A star. Okay, so that's kind of what I was looking for. So this is like in your game, maybe for enemies and stuff, you could do like A star search to find out how to get around barriers or whatever. We also have corridor funnel. Oh, that's post-processing. Edge-centered corridor funnel. What else do we got? So we've got A star. Yeah, okay. So pathfinding algorithm. Is there anything other than A star? There's A star, there's A star, there's A star. And that's so far the only thing I see. Okay. Maybe in 2D that there's a different one. Nope. Okay. In physics 2D, we've got Godot area 2D, body direct state, body pair, Godot physics server 2D, H and CPP. And for these, I'm just curious what they mean by server. I'm guessing it's like a thread that handles stuff, and there's that handles like the physics, and then there's message passing. We've got pointer owners. Circle, shape, create, shape, collide. So this is the thing that's, I guess, computing things like collisions and whatnot. Area attached canvas instance ID. Damped spring. Okay. Okay, we've got some shape segments, convex polygon, shape world boundary. So we can create shapes with a physics 2D server, but what makes it a server? So data, shape, okay. I'm not sure. So here's physics 3D. I think that's basically going to be the same thing as 2D, but in 3 dimensions. I don't know what XR is. Let's see. XR interface. The XR interface is a template class on top of which we build interface to different AR, VR, and tracking SDKs. The idea is that we subclass this class, implement the logic, and then instantiate a singleton of each interface when Godot starts. These instances do not initialize themselves, but register themselves with the AR, VR server. If a user wants to enable AR, VR, I guess they choose the interface they want to use and initialize it. Note that we make this into a fully instantiable class for GD extension support. All right, and we've got Blit to screen. These instances do not initialize themselves, but register themselves with the PRVR server. Okay. I'm curious just how far back this goes. 2 months ago, 6 years ago. Okay. So that's not entirely new. Where are we now? We're in physics server 2d.h. I think this is in another, this is not, so this is in server/physics server 2d. Sorry, this is in Godot/servers, but it's not in the physics server 2d or directory. So there's a layer of hierarchy down from this. And I'm hoping that this tells me what a server is. It could be that a server is just a singleton. We can get total gravity. We've got linear damping. This looks like a lot of the same stuff. Bind method, ray parameters, ray result, point parameters, physics test motion. Okay, class, physics server 2D. It's got a GD class and a singleton. Yeah, maybe it's just a singleton. Let's assume that. I don't think there's any networking. Okay. And we're going to assume the same thing there. Physics server 2D.cpp. See if there's any IPC or messaging or send or notify or okay. I guess before we go, let's at least take a quick look at the docs to see class reference. To see if it will tell us what a server is. We've got HTTP requests, compiling, exporting dedicated servers, WebSockets. Let's see, what was a... Let's try Godot physics server. Physics server 2D is the server responsible for all 2D physics. It can directly create and manipulate all physics objects. What is but will you tell me what a server is in general? Server handler, yeah. Physics in the physics server. What about what is a Godot server? Why does Godot use servers and RIDs? If you ever looked in Godot source code, which I have, and tried to follow the flow of the logic, you most likely noticed that most code related to scene, formats, etc. always ends up in a giant server class. These really large classes, which Godot calls servers, generally abstract some implementation or architecture. No real objects or classes exist, but simple references to a RID type that stands for resource ID, and all functions take these objects as their first argument, except those used to create them. This most likely seems really odd to you if you are a programmer, but there's a quite interesting logic behind it all, mainly related to multi-threading. Okay, so previous engines didn't use this. That was fine. Everything ran in a single thread. Before optimizing, let's take a look at the typical order of execution. Logic, physics, rendering, new frame. The order of events can't be escaped as logic affects physics and rendering needs both information from logic and physics to display. Research on game engine optimization for multiple threads at the time resulted in documentation and papers for a new technique named job scheduling. Most popular engines nowadays use this technique, and this seems perfectly logical. The idea behind this technique is not to alter the sequence order, but to make every stage as parallel as possible. How is this achieved? Rendering, while mostly a sequential process, GPUs are sequential, can be parallelized in a few places, like frustum calling, and in modern APIs such as Vulkan, Metal, or DirectX 12, creation of command lists. For physics, it's more difficult. Physics engines divide their work per frame in the following stages: force integration, compute gravity and external forces and apply them to velocity; broad phase, finding pairs of close objects; near phase, generating collision information of overlapping objects; solver, iterative or LCP approximation to collision resolution; velocity integration, move the objects. Of those, mainly the near phase and the solver steps can be highly parallelized. Physics engines do this via the creation of islands, which are standalone group of objects that don't interact with other groups. This allows them to process them in parallel. If we put all together, rendering a frame with multiple threads splitting in jobs becomes something like this. So thread 1 has got logic, and it's going to send out some physics, and then we're going to synchronize them. And then we're going to do rendering, and we're going to synchronize the rendering. Implementing a job system Godot was too challenging, unfortunately. While for high-end game engines this makes sense, usability would end up severely affected. As Godot aims to be an easy-to-use engine, users would have too many challenges with a system like this. This led to okay, if we put everything together, it becomes obvious that all three tasks can be run in parallel. Okay, this results in multi-threading. How can we make Godot multi-thread but keep it easy to use? The answer to this lies in understanding the following facts. Logic sets information into physics, but it does not need to retrieve data from it. Both logic and physics set information into rendering, neither need to retrieve data. Rendering alone has all the information it needs to display a frame and no one needs to wait for it. Physics needs to set back information, bodies and moved and collisions into the logic layer, but this can be done anytime before the next frame. If we put everything together, it becomes obvious that all three tasks can run in parallel. Basically, the concept of frame time, doing everything less than 160 seconds, no longer exists with this approach. Okay. To make this easier, we came up with the concept of servers. They are called like this because of their requirements. It runs in parallel, could be on the same device or a remote device. An entity that contains all the information and state does all the processing and returns the result. The user has no direct access to it. All communication is done via command sent to a single channel. Does that mean a single channel for all servers, or each server gets its own channel? It's clearly a server pattern. As this is a command-oriented API, it is exposed via a single class representing the server. All right, well, that is interesting and all, but I guess I'm wondering, it does seem like this is the above thing was the correct approach, it seemed to me. You want to send out all of your thingamajiggies and then synchronize them and send them out again. What is this called? Flume, or I'm blanking on the name of the Google thing that does this for like huge batch jobs. MapReduce. I mean, so the idea of having a framework where you send out jobs to be processed in parallel, and then those jobs kind of get collected. I'm not sure if this is similar to scatter gather. I think scatter gather might be something in chips, but this seems like the sort of thing you do want to do. And then the cleverness of making it easy to use would be in making the API simple, so that like a programmer ideally wouldn't, somebody programming a game ideally wouldn't have to think about this at all. They would just use the classes, the API provided by the game engine, and the game engine would know when to do all this. That's my instinct. Again, not knowing anything at all about game engines. I don't know that this won't work, and it seems like this does work and it seems to work in all Godot games. So if that works, then it works. But that might mean that like if you were trying to implement a AAA game, there might be an ultimate bottleneck in Godot that like if it happens, if yours happens to be the corner case where like you really need that extra oomph, this is kind of an intrinsic bottleneck to Godot. So you'd have to do like a complete rewrite to get the next level of oomph. Now I don't know if anyone's really doing that. Maybe Godot is positioning itself as being easy to use, and then if you were so maybe you're not supposed to make those sorts of games in it. I don't know. But yeah, that was cool. There's a lot going on. I still don't feel like I understand a bunch of the first few files I was going through. There seemed to be a lot of stuff there that was kind of maybe boilerplate or it didn't look like ordinary programming. It looked like kind of massaging things into the state it needed to be for Godot to consume them. I don't know. It didn't seem like that was related to servers based on what I just read, but maybe it is related to servers. And then maybe one thing before I go is I would like to know what the GD file extension is called. It is a GD file contains source code written in GD script, which is the scripting language used to create and modify content in Godot engine. Okay, so where's the GD script source code? So it evolved as a custom scripting language to be used with the Godot computer. It's easy to learn, syntax similar to Python, where the code is indented rather than using lots of brackets. I'm not sure if that makes it easy to use. Seems like brackets make things easier to use. They're just harder to type. Okay. Yeah. All right. Well, just out of curiosity, I'm going to see if GD script is in here. I'm kind of guessing that some of the stuff I was looking at was GD script. That modules GD script. Language server. Is this like an LSP server? Yeah, LSP. Well, you've got LSP support. Config byte codegen GD script function lambda callable parser. Okay, so this is the language implementation as a language. And then I'm wondering if what some of the stuff I was looking at before were kind of like, as they're writing the Godot engine, they're kind of binding things to the GD script language. I don't know, but that I guess will be my working hypothesis whenever I come back and take another look at Godot. And that's all for me. Thanks.